Good morning, and thank you all for attending our webinar today on how big data is driving revolution in the travel industry. My name is Natalie Musa, and I'm going to run through a few housekeeping items before I introduce our speaker for the day. The webinar itself will be around 30 minutes, followed by a question and answer period. If you have a question during the presentation, please type it in the questions box, and we will be sure to answer them during the Q&A period at the end of the presentation. Now I'm going to introduce one of our speakers for today, Tom Kersnick. He is the Director of Big Data Solutions here at Pactera and has been working in the big data space since 2008. With that being said, I hope you all enjoy the webinar, and now I'm going to turn it over to Tom.
Thank you, Natalie. Welcome to the webinar today. Appreciate everybody's time. All right, let's dive in then. So a little bit about Pactera first. We're a global strategic consulting firm that's headquartered in China. As you can see here in the presentation, that these are our locations that we have all over the globe. Most of our team is located in the China region. And as we are growing over time, as you can see, these numbers will definitely be increasing. Just a little bit about me. I am the Director of Big Data Solutions, as Natalie just mentioned. I've been in the big data space since 2008. I mostly focus on scalable solution architectures for next generation of analytics. My background involves algorithms, simulations, and modeling development for Fortune 500, 1,000, and 2,000 clients within all verticals. My main focus within the last few years is real-time in-memory architectures and customer-facing API development. That would also include internal and external APIs. Another aspect that I've been working on quite in demand actually is the reporting solution frameworks that are in memory these days. And last but not least, I'm a committer to the open source foundation. So let's talk about our webinar today. Our topics are going to include keys to a successful big data initiative, 5 ways big data technologies can optimize capacity and pricing, how big data can increase look-to-book ratios, the importance of making big data available to non-data scientists, and last but not least, some use cases demonstrating the benefits of big data. So big data is critical. I mean, everybody is realizing that these days. I think as more and more talks come about and the use of the term big data is relevant everywhere, you can notice that it's growing quite rampantly within organizations. And the biggest thing that I'm seeing within clients these days is the lack of sharing data to actually measure the ROI of a big data investment. Most companies have multiple silos of information using structured databases. So the overall goal that they're trying to achieve is to create a pseudo type of data lake that allows all data to be ingested within this distributed platform that can be utilized within verticals internally within the company as well as externally. Next is personalizing marketing communications. That's a really big deal, and I'm going to go into that in a couple slides forward. And not able to link data at the customer levels is another big topic these days. For instance, you've probably heard the term 360-degree view of the consumer. That's a big play when it comes to big data. And another one is data is not collected enough, right? So there's a lack of data that's being stored within structured databases, and that data that's not being stored may be those golden nuggets of revenues that companies are looking for. And last, but too little or no customer consumer data. There's really, what it boils down to is there's no place to really store that in a structured type of environment. You can, but you're going to lose momentum and potential that you may have in gaining new clients. So what initiatives these days are using big data? As you can see here, there's an arrow going forward when it comes to analytical capabilities within companies. companies are now learning that they need to do dynamic simulations, interactions, fraud detection is becoming a big deal, especially in the finance vertical, campaign management within the marketing verticals within companies, behavior modeling of your consumers, clustering of data such as heat maps to understand from point A to point B how a product is doing, and statistical analysis, of course. So now on to a little bit of marketing. As you can see today in this presentation, this screen here, that today's usually involves a campaign, segmenting that campaign, communicating on that segment of that campaign, and then providing that marketing campaign to the consumer. Well, nowadays, when it comes to a big data solution, it's a little bit different. It's a different approach altogether. First, you start with the customer, then you do the behavior analysis and predictive modeling of that customer, then you provide an individual communication, and then you measure and learn and start over again. I think that has a huge effect these days when you can actually understand your consumer a little bit deeper. For instance, let's take the Amazon model, one of my favorites. When I log in or I don't clear my cookies, they are watching me constantly, knowing exactly what I'm looking for, whether it's a baking rack to a particular mobile phone to whatever the product is, and then they start relating other products that they may like to that. Once they gather that information, then they start sending me discounts on those types of products, saying that you may be interested in these, and now we're offering a special deal on such not. That's referred to as an individual communication. And knowing which ones I clicked on versus which ones I didn't, they're basically measuring and understanding me a lot more. And then the next time I log in after I've bought something, then there's a bunch of new products that I could potentially buy. It's very effective. So keys to a successful big data initiative. I get this question a lot within clients, and there's two ways you need to approach this. You need to define what the short term is as well as what the long-term goals are. Short terms has to be usually a specific project. That's where you want to start. And another way to look at this is what cannot be answered today in your structured environments. That is always your starting point with big data initiatives. Once you do that, you can start creating central internal applications such as an API that you feed internally to your clients, or creating custom UIs, or using one of your favorite reporting tools that you use commonly. It's becoming very effective, in utilizing that against a big data lake or a distributed platform of data is becoming extremely effective when it comes to showing the new revenue streams to your C-level execs. And last but not least is everyone wants to know how to predict the consumer, right? It boils down to algorithms, models, testing, and more testing. A big data environment provides a lot of flexibility when it comes to A/B testing, trying new products within certain zip codes or certain regions of the world, and if that doesn't work, try something different. And also, going back to my Amazon model, relating products to that consumer within certain zip codes, offering discounts. I mean, it's limitless. Next is, how do we implement big data? You always begin with your stakeholders, right? Once you understand and identify what your business wants, that's where your starting points are, right? I think nowadays, that when it comes to big data, I think it's really driven from business questions, right? As I mentioned before, what can you not answer today? That's where you start when it comes to with big data initiatives within your organization. Next is consider your culture. You know, you may have some people that are better than others when it comes to actually extracting data and understanding data. Those are your stakeholders. Those would be your data stewards as well. Those would be people that can lead the projects to get complete. Next is, when it comes to these types of projects, you need to set clear goals, right? The goals that you want to meet. Don't set them large. Don't try to boil the ocean. Set small goals first and meet those first, and then build upon those. I think that's a really good approach. Next is creating the plan and establishing your metrics. Those go hand in hand in a lot of ways, because when you're creating your plan, you got to know what metrics you want to look at. Your traditional reporting tools will provide, those kind of common metrics that are across the board that everyone wants to look at. But I think when it comes to establishing metrics, they need to go a little bit deeper when you dive into your consumer. I think that's a really good play to understand what types of things you want to look at, especially from a modeling and an algorithm perspective. Next is deploying the technology. There's so many big data technologies, there's so many NoSQL platforms, there's so many things you can choose from today. It's a huge market. Just make sure that you choose the right technology that will help you grow in the future, not just something that's going to meet your needs today. And last but not least, I mentioned this before, is make big data little. Don't boil the ocean again. It's really important not to. Don't get overwhelmed. Starting with the smaller projects is a really great way to get yourself introduced to this type of scenario and this platform, and allows you to grow and helps your organization grow as well. So what are others doing with big data and travel? Let's talk about this a little bit. Personal preferences is always the key thing from what I can see. When I log into my Virgin America account to Southwest, as everybody knows, rewards is a huge deal. I collect points for my travel all the time, and they add up, and I definitely like it when I see that. So basically spotting when passengers choose window seats for short-haul flights and aisle seats for long-haul flights because they want to stretch their legs, and that pattern can be repeated automatically. Those types of things could be applied to rewards, and they're not easily able to dissect and understand. So you have to build a model or an algorithm around that to do that. Predicting the passenger, understanding what the last 30 flights they've flown, what seats they were in, what beverages they bought, do they like to sit at the front of the plane, do they like to sit in the exit aisle? All that comes into play, right? So combining everything they know about passengers, and historically that sort of information has been fragmented across a variety of systems in their current ecosystems. Now it's time for the data lake to be able to tie all that information together and help predict the passenger more effectively. Another is when people go, where they go, and what preferred brands they use, right? There's a collection and aggregation of information across airlines, hotels, rental car agencies, and credit card companies, and it's using machine learning and advanced analytics to develop rich profiles of segments of travelers to determine this. How many people are traveling, what the brands are, and the class of service. Next is supply and demand. Insights are used by the very same airlines, hotel chains, and car rental agencies to hone their pricing and selection of services, and it helps them make the right cross-sell and upsell and offer a shape of their inventory back to the consumer. Analytics to pricing, inventory, and advertising. All three dimensions shift on a daily basis depending on supply and demand. It's using techniques like lookalike modeling, next best offer analysis, and recommendation engines to push the right offers to customers that fit certain profiles. It's a pre-thinking a lot of patterns that they want to see, but they're constantly changing the experience on a daily basis, even an hourly basis, as demand changes. Next is multiple airlines and hotel chains are pushing revenue management to the next level by calculating, for example, the value of a group of customers who will miss a connection due to a flight delay and determining whether to delay their connecting flight or book them on the next plane. In the hotel chain aspect are doing test and learn analysis in which they've studied just how much to spend and where to spend on renovations. High-end hotels, for example, tend to spring for interior renovations, whereas low-end roadside hotels spend on the exterior to attract drive-by guests. But it goes a lot further than that, for sure. Many hotel chains have also learned to do dynamic pricing based on the source of the reservation. Some online travel brand customers, for example, tend to spend less on food and beverages services than to do other airline travel brand customers that should be figured into pricing. In all these cases, the challenge adds up to big data due to the sheer number of destinations, flights, rooms, prices, and days in the year. So providing intimacy to your customer. As customers continue to seek out individualized purchasing experiences, companies are beginning to realize that their big data initiatives must be optimized in order to provide the personalized level of services that customers demand. Here are a few initiatives that can help ensure a customer for life. Spotting real-time shifts in customer behavior. This will facilitate stronger connections between customer, products, pricing, promotions, and sales. If a promotion does not yield the purchases for which the company was hoping for, what can it do to increase sales with a different promotion? To discover meaningful relationships and trends within its data, companies must learn how to best acquire, analyze, and act on this new information. The data can assist an organization in decisions to bundle services and solutions and determine pricing and packaging. Data categories. Organizations typically divide data into two categories, transactional and sub-transactional data. I recommend focusing on sub-transactional data or clickstream-based data to identify patterns and user intentions. This data helps your organization make useful predictions about customer behaviors. Next is pricing models. Tie the usage to pricing and better match customer behavior to pricing. Using big data solutions, companies can offer at prices and packages that align with their customer actions, while offering the ability to upsell on those actions in parallel. Next is behavior-based customer offers. Track user clickstream behaviors, showing real-time offers to customers based on specific behavior patterns. This architecture allows to create offers and monetize them immediately to drive more revenue. For example, that a well-known travel site will do to increase revenue. They will constantly adjust their prices based on sales of a specific route in real time based on user reactions. And we'll get into that in the use case upcoming here. Next is preventing customer churn. Customers lost to churn need to be replaced, and that's expensive. Keeping customer acquisition costs at less than annual recurring revenue is important with today's products. Sub-transactional data allows your organization to identify when customers begin to use your solutions less frequently or when they are about to make specific mistakes using your products. Analyze this information and put it to good use by fine-tuning the user experience, which will lead to more engaged customers. Next is optimizing capacity and pricing by big data. Collective judgment of a free market. At many companies today, data warehousing is a foundation of reporting analysis initiatives, and that strategy does deliver some value. Sales representatives can answer some basic questions. What is the customer's industry? How large is its business? In what region is it located? But that leaves unanswered the most important question in any sale. What is this particular prospect truly willing to pay? And answering that question means finding important correlations among a much wider variety of factors tucked in piles of data from inside and outside the organization. Next is finding hidden correlations. Pricing analytics today seeks to define thousands of customer segments based on commonalities among dozens or even hundreds of independent variables. By finding these hidden correlations based on rich, deep data histories, we can make smarter decisions and pursue targeting sales, marketing, and pricing strategies much more likely to succeed. That means more revenue and faster sales cycles. Next is let the crowd help you answer the key question. What is the maximum amount this prospect is willing to pay? That analysis starts with an effective segmentation strategy, scanning and rescanning mountains of historical data to create pure groups of customers and prospects who demonstrate similar purchasing behaviors that are meaningfully predictive. With the data volumes usually available, this kind of segmentation can give rise to sparsely problems. But with big data, even a massive number of cells can be populated with enough data to drive statistically significant results. We can verify the value of these dimensions with simple analyses and assemble them into a predictive model. That lets sales and marketing tap that crowd wisdom more effectively and formulate optimal pricing levels and strategies. So where does big data have the greatest impact? One might be tempted to assume that big data-driven predictive models would highly valuable to direct sales teams pushing complex, big-ticket sales. In reality, we're finding that big data's impact can be the highest at sales and marketing organizations with two key characteristics: a large number of SKUs in the tens of thousands, and a network of horizontal customers spanning different industries and geographies. In direct sales of high-priced items, sales teams have fewer transactions to manage, and they can devote resources to individual pricing analysis. However, in distributed organizations, margins are typically quite thin, and the power of pricing is often magnified. Another strategic advantage of data-driven pricing analysis comes from speed. As the saying goes, time kills deals. We can increase win rates significantly without sacrificing margins by presenting the optimal price as early in the sales cycle as possible. By avoiding protracted, outdated negotiation tactics in your closing time, the sales team can avoid disruptions and delays. For sales and marketing organizations seeking a serve footing as they optimize pricing, the best path may be to tap into the hidden power of big data and gain new insights into factors contributing to price elasticity and sensitivity. Price optimization is inevitably going to evolve from an aggregate segmentation approach to a more individualized one, as I mentioned before. With the overwhelming amount of information that is available today, it will drive that revolution. The question I have is on the execution. From what I've seen, new data elements have to be accessible in a real-time price optimization scenario for it to be extremely effective. You will see that in my use case at the end of this webinar. So how can big data increase look-to-book ratios? So most companies utilize your typical look-to-book ratios, such as completed purchases divided by total website visitors, completed purchases divided by total unique visits, completed purchases divided by unique visitors to booking path, and last, unique purchases divided by unique visitors to a booking path. This will get you to a certain point, but what about at a more individualized level? Comparing prices that individuals have paid in the past for similar vacations or how they overall spent on booking. The types of packages they chose and what marketing campaigns entice them to do so. I have just increased the variables that typical look-to-book ratios cannot provide easily. We are now at a point in time where it's important to understand your consumer at the most detailed level. There are a few techniques that I have found very useful in determining a more detailed level of the consumer that involves calculations using algorithms. Some of these are in real time. First one is a stream data model. All of your data is available when and if we want it. Data arrives in a stream or streams, and if it's not processed immediately or stored, then it's lost forever. Moreover, we shall assume that the data arrives so rapidly that it's not feasible to store it all in an active storage, such as a conventional database, and then interact with it at the time of our choosing. The algorithms for processing streams each involve summarization of the stream in some way. We shall start by considering how to make a useful sample of a stream and how to filter a stream to eliminate most of the undesired elements. Then we can show how to estimate the different elements in a stream using much less storage than what would be required from all the elements listed that we've seen. So what that means is that there are many streams, or N is large. We may not be able to store the entire window for every stream. So we need to summarize even these windows. We address the fundamental problem of maintaining an approximate count on the number of ones in that window in the bit stream while using much less space which we need to store in that window itself. This technique is referred to approximating various kinds of sum within the stream. Estimating moments, in other words, the look. This is an important factor that we can measure over time. This is an interesting way to market back to the consumer after this look-to-book session is taking place in real time. The more we capture in our stream, the more factors we can average the time the consumer viewed a particular travel scenario. There are quite a few ways to determine this scenario. Limited pass algorithms. This solution is used to find all or most frequent item sets using at most 2 passes. Always begin with the obvious approach of using a sample of the data rather than the entire data set. An algorithm called SON uses 2 passes, get the exact answer, and lends itself to implementation by MapReduce or another parallel computing regime. Next is maximal matching. These types of algorithms have been studied for years. A few uses is for advertising on the web as well as bridging devices such as mobile, tablets, and PCs. One can get very close to 100% to determine this, but it's always not completely accurate. The most important aspect of this matching technique is the competitive ratio. Next is optimizing solutions. Most users respond to a number of features, right? They like certain flights. They may have a certain famous destination that they like, and perhaps there are a few destinations with a significant following, such as from blogs, etc. All of these types of variables will be considered driving points of your model. The more models and correlations that you have, the more insight you can grasp in understanding your customer. Last is recommendation systems. This is commonly used within most travel platforms, mostly from a marketing and advertising perspective. But what if you want to track pre-logins and understand that user behavior? This requires algorithms and models to be applied by gathering data sets from visitors and building models around those scenarios from a visitor standpoint. That is definitely big data. So let's talk about the future a little bit and the term non-data scientist. Many think that the explosion in big data will create demand for data scientists able to slice and dice data to guide more informed decision-making within the organizations. Others go a step further that a chronic data scientist shortage will hold back the full potential of big data. A proper scalable solution architecture would not only allow growth within your organization, but ease of use over time to solve your biggest revenue-driving hurdles. For years, the BI and data analytics conversation was framed around how to aggregate massive volumes of data and then unleash the data scientists to find value. Today, despite the information deluge, enterprise decision makers are often unable to access the data in a useful way. Here are a few interesting outlooks that come from the non-data scientists. So let's talk about accelerating natural language capabilities. What that means is that you'll be able to speak your query or speak your business solution that you want. In laying out several predictions for big data and data analytics in the coming years, research firm Gartner forecasts that by 2016, 70% of leading BI vendors will have incorporated natural language and spoken word capabilities. Improving natural language queries is essential to the consumerization of big data, as it better enables everyday business users to ask questions of their analytics tool in an intuitive format, such as voice-enabled text, and receive the most relevant and meaningful visualizations results right then and there. Next is look smart and ask very little of the user. Users now expect the answers to be presented via visualization, and they expect to be able to interact with visualization. It's more than a picture telling 1,000 words, right? It's the picture becoming the interaction. Next is creating a social learning layer. This is one of my favorites. By building a social learning layer into data analytics tools, user behavior can be learned by the tool, so it can anticipate queries and be trained to the specific needs of each user. By making the tool as seamless as possible for business users, there is a less chance the tool will waste time, resources, or deliver results different than what others users are looking at. And last is, or second to last, deflate big data. An enterprise should start with a small set of users it believes will experience the most immediate value. And then, the last but not least is focus on the right kind of mobility. Today's big data analytics platform must consumerize the user experience by removing spreadsheets and reports and place the power of analytics in the hands of users of any level and analytics expertise. This consumerized data analytics experience must enable mobility on any smartphone or tablet device with complete flexibility on how data can be visualized. It is this flexibility for visualizing data in real time on mobile devices rather than just making massive volumes of data accessible to mobile users that will help data analytics providers realize the most from their mobile investments. A consumerized big data experience is in sight for enterprises. As long as data analytics providers remain focused on features and functionalities that ultimately will matter to most business users, big data analytics is the leading charge to reinvent enterprise applications, bringing our consumer-level expectations to our everyday workplace. So let's jump into a few use cases now. First, we'll start with this one that's dealing with some customer insight behavior use case for a retail conglomerate that we help out. So the first step here is dealing with customer analytics. This is pretty common across the board. Market segmentation, upsell, sales lead optimization, predictive price optimization, predictive inventory planning, operational analysis, and customer risk on investment and lifetime value of your customer. All very important. And last but not least, probably the most important in my mind is customer satisfaction. So for this client, the one thing that we focus on the most is trying to understand customer behavior and preferences. We're rapidly testing and building behavioral models for them and combining disparate data sources, transactional, social, log files, everything. So basically it's the 360-degree view of the consumer. It's very important to have all aspects of what products they're using, what they're trying to do, what they're saying on social sites, and applying that all to the customer experience. And that goes back in hand with what I mentioned about understanding the consumer and making sure that you keep the customer for the long-term haul. Next is structure and analyze data within a big data refinery. A big data refinery could be anything, right? It could be a NoSQL platform that you use, or it could be Hadoop. It could be anything where you can actually store massive amounts of information. In this case, it's Hadoop. And we utilize this as a data stage environment for everything, right? From social to financial data to everything that's related to that consumer. That way we can identify patterns and recognitions to find indicators to market back to them. So we utilize this more or less for marketing initiatives, financial growth of that customer, understanding things that they're looking at the consumer level, right? This is not by zip code or by state. It's actually that consumer and what they're doing. We're tying in not only their mobile device, but they're tying in the PC that's associated to that user and understand what they're looking at and when. That's the most important. And last is feature extraction to find root causes. We're defining attributes and modeling statistical significance of that consumer and combining sequences of attributes and actions to factor in. So basically, we can take variables in, and we can put new variables in and out all the time. That allows them to understand that consumer to see how we can make money from them going forward. Next is customer loyalty, probably one of the most important things. So we're looking at comparison shopping as making a retail hyper-intensive act within this organization. We're offering discount programs, independent email correspondence to entice them. We're promoting the brand. We're providing a lot more detail based on what they're looking for. We're also doing customer life cycle. It's just more than purchases. It's following up with them to make sure they're happy after the purchases, bridging the gap between other purchases that they have, recommending more types of items to them. There's all sorts of channels that we're taking on here. We're just making sure that the engagement is completely personalized and we are fully aware of the customer awareness that we have with them. Next is the architecture. So, a lot of clients ask us, and for this client especially, they were very concerned about their current, investment in their EDW ecosystem. As you can see here, what we're doing is we're taking steps to apply their current ecosystem, let's say use day in and day out for their structure reporting, and applying new solution architecture around that solution that they can utilize. So one of the things that we focused on was creating a real-time in-memory solution so they can actually track what's taking place from a social aspect, as well as derive algorithms for marketing for them to actually market new products, etc. Next is that we're storing all of this data in Hadoop from a storage perspective so that we can do year-over-year trending and we can understand the consumer better. We can do product A/B testing. We can test out other types of products. We can just understand the consumer from a broad perspective, etc. Last is we're doing models and algorithms and simulations of this data, not only from their current ecosystem, the EDW, but in real time as well as the year-over-year data that we're storing in Hadoop. It's extremely effective architecture because you can see on the left is, yeah, you're getting the information from your blog, your Yammers, and your LinkedIn accounts, etc., and Google Analytics as well, but we're also getting data from their current ecosystems, their current structured databases, as well as unstructured logs or anything else from third-party clients. It's all being ingested through this platform and into Hadoop that allows them to store all this data and come up with relevant trends from that consumer. Next is a predictive analysis use case for an online travel company. This use case has been presented on a few blogs. You'll be able to see that. And you can see that when we were working on this, this was more from a real-time perspective for this client. So the idea here was determine flight cost by variance determination. As most of you know, if you go to your sites such as TravelZoo or Kayak, that type of thing, you'll notice that they provide you prices and they also provide you other sites that are associated to that site that are a partner of them. If you keep your cookies and you leave that site or those sites and you come back, the price may decrease or increase based on people who've also looked at that particular deal or who have bought it. So this is keeping track of you and your scenarios. The reason they're doing that is they're trying to figure out a way to understand how they can make more money off of you or how to actually get you to entice to buy. So it deals with views, marketing pricing, time, and availability. So flight cost is one of the algorithm methods used to increase and decrease this revenue. It's used from web applications, mobile applications. It's fed into Hadoop at the end as well, so they can look at it later on down the line from year-over-year standpoint. It's fed in real time from a mobile perspective to that consumer as well as to internal financial departments to understand what the revenue streams that are coming in per, let's say, every 15 minutes to every 30 minutes. And that's pretty much it. So this allows them the flexibility, and this goes right back to the architecture that I've shown before, is that this type of scenario is applied to where you can actually monitor that consumer. Within that real-time in-memory solution, there's a lot of algorithms and models being placed at that time, watching you as you choose the types of scenarios that you may be interested in purchasing. It's a good stream to way to understand the consumer to market to the next individual that may come in. So what does Pactera offer? We focus on in the big data solution architecture department. We do in-memory solutions, scalable distributed platforms. We provide next generation analytics such as models, algorithms, and simulations, and we stride on visualization. Another aspect that we help embark upon is helping companies drive more operational efficiencies from existing investments. We provide monitoring, security, as well as just overall understanding of your current environment and how a big data ecosystem can apply and add value, not only in the short term, but the long term. And not only the last but not least, we ask the right questions. I think that, as I mentioned before, big data ecosystems are driven from questions. What questions are not being answered today? That's where we come into play, because not only do we know how to do that, but then we can actually apply the correct architecture that can help your organization grow for the long term. The idea is to impact both the customer intelligence as well as the operational efficiency by making everything immediately actionable. Well, I'd like to thank you very much for taking the time today to listen to my webinar. Hopefully this was enlightening and you learned a bunch of things. The more, as you know, the more data you have, the more of an understanding not only from a modeling perspective, but also a deep understanding of the consumer behavior. And I'd like to turn it over to Natalie. Thank you very much.
Thanks, Tom, for your time today. There's a few questions that have come in, so we will address those really quick. The first question that's come in your first use case, you presented an architecture that was interesting in nature. I was under the impression that big data was going to replace our current EDW. Is that not the case? Tom?
Yeah, so as I mentioned before, all companies have made a really initial investment in their current EDW ecosystem. That is never going to be replaced. That structured environment will always be there and will always be used. The idea is to apply another ecosystem in parallel to where you can do the deep dive analytics that's necessary that you can't do in a normal structured environment. I think both of these are going to they come into play hand in hand, right? Now you can always take your data from your unstructured, semi-structured environment in your big data ecosystem and aggregate it and conform it to your current ecosystem, which will allow you to do reporting. It's that flexible. Or the other way is bring in your structured data into your big data ecosystem so you can do correlations of your consumers. It all ties together and it all plays very nicely with each other.
Great, thanks Tom. And we have one other question that's come in. How would one start a big data project that can add value immediately?
Well, okay. Well, I would suggest that, as I mentioned before, make big data little, right? Come up with projects that you can't normally do in your current ecosystem, your current EDW, and think about how you can tie in not only your social information, but also your unstructured machine logs or anything that's related. That way you can start with a pseudo project of the 360-degree view of your consumer. It's always a good starting point, and then from there you can build upon that.
Great. Thanks, Tom, and thanks for your time today, and thank you for all of you who attended this session. If you would like a copy of the webinar, we will be posting it to our Pactera US YouTube page later on today. And if you have any further questions, all attendees will be receiving a follow-up email with Tom's contact information. So thank you all for joining our webinar today. Hope you have a great rest of the day.